All right, day 3, we're going to talk about some special right triangles, and I'm sure you've heard of these too. This was definitely something you did in geometry, but I think we do this, and then this is going to make the day 4 and 5 go a lot easier if you really focus in on these. So make sure you know these ratios. But our learning target is I can use special triangle ratios to find missing sides and angles in 2 special kinds of triangles, 45, 45, 90, and 30, 60, 90 triangles. So looking at these guys, first off, if I give you one angle is 45, that's 90, that's 45, this one has to be 45. And just to, probably what makes this mostly easier, or so much easier, is if these are the same degrees, then this is an isosceles triangle, meaning that these 2 sides are exactly the same. So this being 8 means that's going to be 8 too. Now if we don't know that, let's say we weren't quite sure of that, we can use, because it says use right triangle trig to find the missing sides. So let's just call this side right here x for right now, and let's solve for x and verify that it is in fact 8. Okay, so if I use, let's say this 45, the one that was given, the 45-degree angle, opposite over adjacent would be tangent. So tangent 45 is going to be opposite over adjacent. Okay. So if I go to solve for x, multiply both sides by 8, so multiply by 8, crosses that out, and then in your calculator, we're going to go 8 tan 45, and you get 8 for an answer. So it is in fact 8 equals 8. In fact, if I do just tangent 45, remember, tangent is opposite over adjacent, so what should the ratio of these sides be? 1, meaning they're the same thing. Okay, they're the exact same thing. Now, I can use trig to find this other side. I think it's almost, I kind of want to use Pythagorean theorem instead, because then I can leave things in radical form and show you the ratio in radical form. So if this is the hypotenuse, remember a squared plus b squared equals c squared. So I'll call this y, so we'll say so 8 squared plus this 8 squared is going to equal y squared. So we got 64 plus 64, okay, so 64 plus 64 is going to be 128, so 128 equals y squared. To solve for y, I need a square root, and when you're looking at 128, because we want to factor it and pull out any pairs that we see. So the easiest pair I see, so I see a 64 and a 2, and then 64 would be 8 times 8. And if you remember, it doesn't have to be prime, just as long as I see a pair. So this would be a pair, here would be 8. So there's a pair of 8s under there. So the square root of 8 times 8 is just 8, so I can pull an 8 out front. So this would equal, so y would equal 8 with a radical 2, the 2 left over underneath there. Okay, so the hypotenuse is 8 radical 2, so you get 8, 8, 8 radical 2. It's not a coincidence that these 8s all match, and that this one just has to be multiplied by radical 2. That's kind of the ratio, that's the shortcut. Okay, so 8, 8, 8 radical 2. And what it is, I'm just going to put it down here. I think we're getting ahead of ourselves, but that's okay. If this side was x, this side would also be x, and this would be x radical 2. So hopefully you remember that. So 1, 1, radical 2. If I put it here, it would be 1, 1, and then 1 times radical 2. If we did Pythagorean theorem here, 1 squared plus 1 squared needs to equal hypotenuse squared. Well, 1 plus 1 is 2, so 2 equals c squared, square root both sides, c equals radical 2. So that's kind of the easier one to remember, I think, the 45, 45, 90. So the legs are going to be equal, the hypotenuse is radical 2 times bigger. Okay, so if I know this, multiply by radical 2 to go this way. Also, if you know the hypotenuse, you want to go backwards, divide by radical 2. So we'll do a few of those on the back side. Now 30, 60, 90 triangles, I wish I would have edited this before I printed. This is probably more accurate right here to say that this is 30 and this is 60. So let's kind of ignore this. I want to write it just so it looks a little more scaled. So think about it that way. Okay, so 30, 60, 90, here's the hypotenuse of 12. And if I use my right triangle trig, Let's say this is x over here. So let's call that side x. So I've got angle 30 opposite hypotenuse. So sine 30 equals x over 12. If I multiply both sides by 12, so 12 sine 30 is 6. Which, if you notice, is exactly half of 12. Well, why did that come out to be 6? Well, if you type in sine 30, it's saying that if you're looking at a 30-degree angle, the opposite and hypotenuse would be a ratio of 0.5. So this will always be half of that. Okay, or this will always be double that, depending on which direction you're going there. So yeah, if you've got 30, and what's happening with that, maybe I can go back even further to it. This will probably make even more sense, hopefully. Think about an equilateral triangle. Let's say all of these sides are the same and all of these are 60s. And let's pretend like every side has length of 2. Let's just say it's an equilateral triangle, all side lengths are 2. If I drop an altitude right down the middle there, this 60-degree angle is now 30 and 30. This side is no longer 2, it's now 1. 1 to 2 ratio. Okay, so this is 30 degrees, that's 60. I'm sorry, this is 30 degrees, so it's the side opposite to 30 is half the hypotenuse. So the smallest side is half the biggest side. It's the medium side that kind of throws things off then. But if we wanted to do this, again, I like to use Pythagorean theorem to show that the radicals here. So this is a leg is 6, hypotenuse is 12. And let's just call this y. So y squared plus 6 squared equals 12 squared. So I could subtract 6 squared from both sides. So y squared is going to equal, and this would be 144 minus 36. So 144 minus 36 is 108. So when I go to square root that, let's try to simplify the radical. So let's see what we can take out of there. And I'm thinking I can do 36 times 3. Then 36 is 6 times 6, and I see a pair. So I could take the 6 out front with a radical 3 underneath, so this would equal 6 radical 3. Well, notice this was 6, this is now 6 radical 3. Okay, so, and that is a true ratio. Whatever this is, multiply by radical 3, and that's what that is. So using those shortcuts here, I got the smallest side is 10. What would be the hypotenuse? The biggest side? Double that, 20. You can use your right triangle trig if you want. Maybe we'll do that in a second. If this is 10, this is radical 3 times bigger, so this is 10 radical 3. I want to check those. Remember, we'll call this x. So 30 sine of 30 equals 10 over x. So I'm going to do 10 divided by sine 30. So 10 divided by sine 30, 20. That's what that equals. And we can do this, it will give us the decimal form of 10 radical 3. But the thing is, we want to memorize these because that's more exact. 10 radical 3 is much more exact than what the calculator will give me. Yeah, the calculator is going to give you a decimal. Math Excel is going to want radicals in your answer. I'm going to want it on the quiz. So again, let's redraw this a little more realistic here. Let's say this is 60, and just ignore the rest of this. I'll do this. This will help us ignore everything there. So let's say that that's 60, and this is 1. So if the smallest side is 1, this would be 2, this would be radical 3. So basically, whatever this is, I'm on it fixed, so I try to fix a little bit so it looks a little more scaled. If this side was x, this would be 2x. So if this is 5, that's 2 times 5. If it's 13, that's 2 times 13. And then this would be x radical 3. So whatever this is, you multiply by radical 3 to get that way. Now if you have this side, divide by radical 3 to come back this way. Okay, so let's do some of those on the back side. Just got a few, we're going to do real fast. And I'm going to draw this at the top here. So if it's a, so 45, 45, you got x, x, x radical 2. If it's a 30, 60, 90, so 30, 60, it's going to be x, 2x, x radical 3. Okay, so on this one, it says find all the missing sides. Exactly, this is not going to take long. I want to be able to do this quickly. I don't need a calculator, and I'm going to use a calculator on this one. So 45, 45, 90, if this is x, they're the same, so this is 6. If I want that side, take x times radical 2, so take, in this case, x is 6, take 6 radical 2, and that's your answer, you're done. Here's your 30, 60, small side is 4. Oh, not even on the page, on the camera. So 60, here's a small side is 4. The biggest side is double that, 8. The medium side is the smallest side times radical 3. So this would be 4 radical 3. Done. Didn't have to use a calculator. Where it gets tricky is if I know the hypotenuse, well, some people I think of this as that's x radical 2. If I can figure out what x is, I got the side. So 8 equals x times radical 2. Think of it that way. Like this is the x radical 2 part of the triangle. Divide by radical 2. The hardest part now is rationalizing. So maybe you forget how to rationalize, but if I have 8 over radical 2, to rationalize that, I'm going to multiply by radical 2 over radical 2. And that way there's no more radicals in the bottom. So this would be 8 radical 2 over 2. And notice the 8 and the 2 will reduce. So 4 and 1, so this would be 4 radical 2. And this would also be 4 radical 2 because they're the same. So maybe some of you in geometry realize a shortcut here if you're going this way. It's you cut that number in half and then multiply by radical 2. That's the same thing as dividing by radical 2. Okay, so yeah, maybe I'll just down here draw another triangle. It's going to be even faster. So let's say this was 10. This was 10. I want to find this side. Well, I need to take 10 divided by radical 2. The shortcut is take half of that and multiply by radical 2. Because 5 radical 2. So if I have 10 divided by radical 2, multiply by radical 2, so that's 10 radical 2. This is 2. Here's why I'm dividing by 2. When you rationalize, you divide it by 2 and got 5. So that's kind of a shortcut too. And this one's all about shortcuts. So if this is 30, it's actually looks more like this. So if the hypotenuse is 10, and that means the small side is 5, and the medium side is 5 radical 3. Okay, so 30, 60, shortening that up a little bit, try to make it look more like a 36 and 80 triangle. Here, not too bad. So now this is the medium side. We said the medium side, the ratio to get to the smallest side, because the smallest side is always off the smallest angle, so if I want to be a little more accurate, I could draw something like this and put the 60 there. Just make it a little bit more of a 36 and 80 triangle. I need to divide by radical 3. So it's kind of the same idea here. I'm going to slap a radical 3 on there, but then I'm going to take 6 divided by 3. Because 6 divided by radical 3, I'm going to multiply by radical 3 over radical 3, so it'd be 6 radical 3. And this is why I'm dividing by 3, is because you rationalize, you have a 3 on bottom. So it'd be 2 radical 3. And then the hypotenuse, double that, 2 radical 3 doubled is 4 radical 3. Okay. And then, let's see, this guy here, 7 radical 2. Well, this is also going to be 7 radical 2, because if this is 45, that's 45. It's isosceles, they're equal. To go to the hypotenuse, I'm going to multiply by radical 2. So it'd be 7 radical 2 times radical 2. Well, radical 2 times radical 2 is 2. 7 times 2 is 14. So that would equal 14. Okay, so it's a lot of multiplying by radical 2, divide by radical 2 kind of stuff. So hopefully that rings a bell. Yeah, it's definitely worth your time to memorize these, though. We don't want to use any other method. We want to memorize and make things faster.